Hello, I'm Jordan and I'll be presenting on my final year project titled Time Expression and Name Entity Recognition for Sentiment Analysis. So to start off, this project mainly revolves around sentiment analysis. To perform sentiment analysis, there are two main approaches, symbolic AI as well as sub-symbolic AI. In recent times, sub-symbolic AI, such as deep learning, has become much more popular for sentiment analysis compared to classic symbolic AI. The two approaches are very different, but despite their differences, SenticNet is a novel framework that has managed to tap on both their strengths. Seeing this, it will be interesting to see how such an ensemble approach compares to popular sub-symbolic AI. Also, it is noted that most of the time, sentiment analysis is performed at the sentence level, but it will be more meaningful to know what specific entities the sentiments are for. This is because most of the time, people express their sentiments about a specific entity like a person or an object. So with these ideas in mind, this project has two objectives. The first is to see how SenticNet compares with sub-symbolic AI for sentence-level sentiment analysis. The second objective is to perform entity-level sentiment analysis. We will introduce a novel method that looks at the grammatical structure of sentences to extract entities and their related descriptions in order to determine their associated sentiments. So to achieve these objectives, we need a suitable data set. For our project, we need one that contains a variety of entities. So we have chosen a data set consisting of Amazon product reviews, where the entities are the products purchased and the sentiments are determined by the corresponding rating. We split the data set into a training set and a testing set. The sub-symbolic models will be trained on the training data, while SenticNet does not require any training. All three models will then be tested on the testing set. So let's look at the models we will use. The first is the ensemble framework SenticNet. It works by first detecting concepts in text using linguistic patterns. It then generalizes these concepts to common sense ones using deep learning. Finally, it looks up these concepts in its knowledge base to determine their associated polarities. Then, we have the sub-symbolic models. The first one is the CNN-LSTM. It is actually a hybrid model that consists of two models, the CNN and the LSTM. The CNN model will apply convolutions on the input text to extract the most important features that represent them. And the LSTM model will then learn how the sequencing of these features affects its polarity. And the last model is the BERT model. BERT is a transformer-based model that uses a self-attention mechanism to learn how different words are related to each other in a sentence. Words that have relations to each other will have higher attention scores between them. This allows BERT to capture the context and meaning of words in sentences. So here, the sentence level prediction results for the three models are shown. We can see that all three models perform well, but the sub-symbolic models perform better than SenticNet, mainly because they were trained beforehand on the training data. Upon deeper inspection, we found three main shortcomings in the SenticNet framework. The first is that it does not undergo any training to understand how the lingo of the text affects its polarity. The second is that it sometimes detects concepts in text that do not actually convey any polarity. And the last is that it lacks some emotion-conveying concepts in its knowledge base. So from this, we can see that despite being black boxes, sub-symbolic AI is still useful for sentiment analysis. So all three models correctly predicted most sentiments as positive. But what entities are these sentiments for? To find out, we have to determine the entities in text as well as their corresponding descriptions to find out the related sentiments. This is where we perform entity-level sentiment analysis. To do this, we use dependency parsing to extract the grammatical structure of the sentence. From the structure, the relationships between words can be identified. And from the relationships, the entities and their corresponding descriptions can be determined. Generally, nouns are extracted as entities and adjectives are extracted as descriptions. So, we apply dependency parsing on the testing set to extract entities and their descriptions. We then select 6 popular entities shown in the table below to perform sentiment prediction on. We use the 3 previous models to predict the sentiments for their corresponding descriptions, and we then analyze what insights these entity-specific sentiments can give us. So, from the prediction results, we can see that all 3 models predict the majority of sentiments for the 6 entities as positive. And all 3 also agree that batteries have the lowest percentage of positive sentiments as well as the highest percentage of negative ones. So, what do these insights give us? Well, for Amazon, they realized that electronic gadgets are hugely popular and loved by their customers. Hence, they can focus more on selling electronic products to gain more revenue. Customers are also satisfied with the prices, so they can work more on pricing discount strategies as well. We can see from this that entity-level sentiment analysis is more meaningful and can give much more insights compared to traditional sentence-level analysis. So in conclusion, from this project, we see how SenticNet compares with sub-symbolic AI for sentiment analysis. We see that it has some shortcomings, but is still able to perform well and is able to give machines some common sense reasoning of natural language too. And at the same time, we see that despite being a black box with no true logical understanding of text, sub-symbolic AI is still useful in sentiment analysis. Finally, we see that entity-level sentiment analysis can give us much more insights than sentence-level analysis by determining the sentiments for the specific entities in text. These insights can help businesses make better decisions. And so, this also highlights the importance of name entity recognition in sentiment analysis. So, that sums up the findings of this project. I hope you enjoyed it. Thank you for listening.